Dear friends, let us continue our discussion on control structures in C. In this session, we will cover the topic loop control statements and unconditional control statements. The versatility of the computer lies in its ability to perform a set of instructions repeatedly. This involves repeating some portion of the program either a specified number of times until a particular condition is being satisfied. There are methods by which we can repeat a part of program. Usually, there are circumstances where you want to execute the same statements many times. For instance, you want to print the same word 10 times. You could type 10 printf functions, but it is easier to use a loop. The only thing you have to do is to set up a loop that executes the same printf function 10 times. In looping, sequences of statements are executed until some conditions are satisfied. A loop control construct therefore consists of two segments. First one, control statement, and two, body of the loop. The control statements test certain conditions and then direct the repeated execution of the statements contained in the body of the loop. Depending on the position of control statement in the loop, control structures can be classified into two. First one, entry controlled loop, pre-test loop. Second one, exit controlled loop or post-test loop. In entry control loop, the conditions are tested before the execution of the body part of the loop. If the conditions are not satisfied, the body of the loop will not be executed. In case of an exit controlled loop, the test is performed at the end of the body of the loop, and therefore, the body is executed unconditionally for the first time. A looping process normally consists of 4 steps. First one, initializing and setting of a conditional variable. Second one, execution of the statements inside the loop. Third, incrementing or updating the condition variable. Fourth one, test for a specified value of the condition variable for execution of the loop. Based on the nature of the control variable and the kind of variable assigned to it, the loop can be broadly classified into two categories. First one, counter controlled loop. Counter controlled loop are loop which will repeat a specified number of times where the number of repetitions is fixed prior to entering the loop. Many processing applications have this requirement. Second one, Sentinel controlled loop. In a Sentinel controlled loop, a special value called a Sentinel value is used to change the loop control expression from true to false. For example, when reading data, we may indicate the end of data by a special value like -1 or 999. A Sentinel control loop is often called indefinite repetition loop because the number of repetitions is not known before the loop being executed. The flowchart for the entry control loop is shown in the screen. Entry, then test condition. If it is true, then it will go to the body of the loop. If it is false, exit. Next, we will see the flowchart representation for the exit controlled loop and body of the loop, then test condition. If it is false, then again go to the entry, or if it is true, exit. Next, we will understand the usage of a simple entry control loop structure, the while construct. The while loop is used when a statement is to be executed repeatedly until a given condition is satisfied. The loop is terminated when the expression yields false value. Perhaps you want to calculate gross salaries of 10 different persons, or you want to convert temperatures from centigrade to Fahrenheit for 25 different cities. You can easily implement this with the help of while loop. The basic format of the while loop is while within the braces expression, curly braces, body of the loop and close the curly brace. As I told earlier, the while loop is an entry controlled loop in which the test condition is checked first, and if the condition is satisfied, the body of the loop is executed and the conditional parameter is updated. Again, the conditional instruction is checked and the above steps are repeated until the condition becomes false. On exit, the program execution is continued with the very next sentence after the end of the loop. Let us now understand the flow of while loop with the help of the flowchart. Entry, expression. If expression is true, body of the loop, then again it is repeating. If the expression is false, exit. So long as the expression evaluates to a non-zero value, the statements within the loop would get executed. The condition being tested may use relational or logical operators as shown in the following examples. While within the brace I less than or equal to 10, close the brace, or while I greater than or equal to 10 and j less than or equal to 15, while j greater than 10 and b less than 15 or c less than 20, close the braces. The statements within the loop may be single line or a block of statements. In the first case, parentheses are optional. For example, while n greater than 1, n minus minus semicolon is same as while I greater than 1 within the braces n minus minus semicolon. As a rule, the while must test a condition that will eventually becomes false, otherwise the loop executed forever indefinitely. That is, when an expression returns always true value, then the loop becomes an infinite one. For example, while 1 within the braces statement semicolon, close the brace, is an infinite loop. It is equivalently written as while not equal to 0 within the braces statement to form an infinite loop. Now, let us go through a demonstration of C program which uses a while loop to find the solution of the equation y is equal to x to the power n. Main within the braces declare the variable int count n, float x comma y, printf enter the value of x and n, scanf percentage f percentage d ampersand sign x ampersand sign n, y is equal to 1, count equal to 1 semicolon, while count less than or equal to n within the braces y equal to y into x semicolon, count plus plus semicolon and close the brace. Printf x is equal to percentage f x to power n percentage f comma x comma y, then close the brace. Next, we will move to another entry controlled loop named for loop structure, the for construct. It is the most powerful loop construct used frequently in many programs. The for loop structure allows us to specify three things about a loop in a single line. First one, setting a loop counter to an initial value. Second one, testing the loop counter to determine whether its value has reached the number of the repetitions desired. Third one, update the value of loop counter each time the program segment within the loop has been executed. General form of the for loop is for within the braces expression 1 semicolon, expression 2 semicolon, expression 3 curly braces, body of the loop. The execution of the for loop is as follows. In expression 1, control variables are initialized using assignment operator. In expression 2, the value of the control variable is tested using the test condition. Usually, relational expressions are used for conditional checking. Third one, body part is executed and the control is transferred back to the for statement. The control variable is altered in expression 3 using assignment statement, and the new value of the control variable is tested again to see whether the condition is satisfied, and the process is continued until the condition becomes success. Next, we will understand the use of for loop with the help of a program to calculate simple interest for 3 sets of P, N and R. Hash include stdio.h. Main within the braces declare the variable int P, N count, float R, Si. For within the braces count equal to 1 semicolon, count less than or equal to 3 semicolon, count equal to count plus 1. Within the braces printf enter values of P, N and R. Scanf %d, %f, ampersand sign P, ampersand sign N, ampersand sign R. Si equal to P into N into R divided by 100. Printf simple interest equal to Rs %f Si, close the braces. If this program is compared with one written using while, it can be seen that the 3 steps initialization, testing and instrumentation required for the loop construct have now been incorporated in the for statement. Let us now examine how the for statement gets executed in the program. When the for statement is executed for the first time, the value of count is set to an initial value 1. Now, the condition count less than or equal to 3 is tested. Since count is 1, the condition is satisfied and the body of the loop is executed for the first time. Upon reaching the closing braces of 4, control is sent back to the for statement, where the value of count is gets incremented by 1. Again the test is performed to check whether the new value of count exceeds 3. If the value of count is still within the range 1 to 3, the statements within the braces of 4 are executed again. The body of the for loop continues to get executed till count does not exceed the final value 3. When count reaches the value 4, the control exits from the loop and it transfers to the statement, if any, immediately after the body of the for. Additional features of for loop: more than one variable can be initialized in expression 1 and more than one expressions can be used in the place of expression 2 and expression 3 respectively, and these multiple sections are separated by commas. For example, for m is equal to 50, comma, n is equal to 1, semicolon, n less than or equal to m, semicolon, n is equal to n plus 1, comma, m is equal to m minus 1. Within the braces p is equal to m by n, semicolon, printf %d, n, comma, m, comma, p and close the brace. Nesting of for loops. One for loop within another for loop is known as nesting of for loops. For example, for I is equal to 1, semicolon, I less than m, semicolon, I plus plus, within the brace for j equal to 1, semicolon, j less than n, semicolon, j plus plus, then close the braces. Let us now move to another control structure named do while, which is a exit control loop. The do while construct. The do while construct is an exit control loop structure in which the loop statement consists of a block of code and a Boolean condition. First the code block is executed and then the condition is evaluated. If the condition is true, the code block is executed again and again until the condition becomes false. The normal syntax of do while construct is do within the braces body of the loop, close the brace, and while within braces test condition, semicolon. Let us see the flowchart representation of the do while loop: entry and executable statements, then test condition. If the condition is true, again it will go to the execution statement, then false, exit. Here at first the block of statements are executed present in the body of the loop, and at the end while statement is executed. If the result condition is true, then program control goes to evaluate the body of the loop once again. This process continues till condition is true. When it becomes false, then the loop terminates. It is important to place a semicolon after closing the test condition in do while construct. Since the loop construct executes the statements within the body of the loop before the test condition is evaluated, the minimum number of times the do while loop is executed is 1. The while construct, on the other hand, will not execute its statements if the condition fails for the first time. This difference is brought about more clearly with the help of a program. Hash include stdio.h main within the braces while 5 less than 1 printf hello world, close the brace. Here, since the condition fails the first time itself, the printf will not get executed at all. Let us now write the same program using do while loop. Hash include stdio.h main within the braces do open brace printf hello world, close the brace while 5 less than 1 semicolon and close the brace. In this program, the printf would be executed once, since first the body of the loop is executed and then the condition is tested. Unconditional control structures. The break statement. We often come across situations where we want to jump out of a loop instantly without waiting to get back to the conditional test. The keyword breaks allows us to do this. When break is encountered inside any loop or in a switch case control structure, it terminates the execution at that point and transfer execution control to the statement immediately following the loop or switch case construct. Thus, it indulges an early exit from any loop or switch case construct statement. The general syntax is break semicolon. Let us consider C program to determine whether a number is prime or not. As you are aware, a prime number is one which is divisible only by 1 or itself. The idea that we have to test whether a number is prime or not is to divide it successively by all numbers from 2 to 1 less than itself. If remainder of any of these divisions is 0, the number is not a prime. If no division yields a 0, then the number is a prime number. Let us now go through the program that implements this logic. Hash include stdio.h main within the braces declare the variable int num and I, printf enter a number, scanf %d ampersand sign num, I equal to 2 semicolon, while I less than or equal to num minus 1 within the braces if num %I equal to 0 printf not a prime number, break semicolon, then close the brace, I plus plus semicolon and close the brace. If I equal to num, printf prime number and close the brace. In this program, the moment num %I turn out to be 0, that is num is exactly divisible by I, the message not a prime number is printed and the control breaks out of the while loop. Why does the program require the if statement after the while loop at all? Well, there are two ways the control could have reached outside the while loop. First one, it is jumped out because the number proved to be not a prime. Second, the loop came to an end because the value of I becomes equal to num. When the loop terminates in the second case, it means that there was no number between 2 to num minus 1 that could exactly divide num, that is num is indeed a prime. If this is true, the program should print out the message prime number. The keyword break breaks the control only from the loop in which it is placed. Consider a program which illustrates this fact. Hash include stdio.h main within the brace declare the variable I equal to 1, j equal to 1, while I plus plus less than or equal to 100 open brace, while j plus plus less than or equal to 200 again open brace if j equal to 150 break semicolon else printf percentage d I comma j close the braces. Here when j equals 150 break takes the control outside the inner while only, since it is placed inside the inner while. The continue statement. In some programming situations, we want to take the control to the beginning of the loop by passing the statements inside the loop which have not yet been executed. The keyword continue allows us to do this. When continue is encountered inside any loop, control automatically passes to the beginning of the loop. That means, it is used within the loop structure to end the execution of the current iteration and proceed to the next iteration. Format is continue semicolon. A continue is usually associated with an if. Let us consider a program to clearly understand the usage of continue statement. Hash include stdio.h main within the brace int ij for I equal to 1 semicolon I less than or equal to 2 semicolon I plus plus within the brace for j equal to 1 j less than or equal to 2 semicolon j plus plus within the brace if I equal to j continue semicolon printf percentage d I comma j, then close the braces, and output of the program will be 1 2 2 1. Note that when the value of I equals that of j, the continue statement takes the control to the beginning of the inner loop, bypassing rest of the statements pending execution in the inner for loop. Go to and label construct. The go to construct causes an unconditional transfer of execution. Formally, the go to statement is never necessary, and in practice it is almost always easy to write code without it. The general format is label colon go to label semicolon, where label is an identifier and not a number. The identifier following go to is a statement label and it is not declared. The name of the statement label can also be used as a variable name in the same program if it is declared properly. The compiler identifies this name as a label, it appears in a go to statement, and as a variable if it is appeared in an expression. As far as possible, use of go to construct is to be avoided, since it affects structured programming. Nevertheless, there are certain situations where go tos may find a place to make the program simpler. The most common is to abandon processing in some deeply nested structure, such as breaking out of 2 or more loops at once. The break statement cannot be used directly, since it only exits from the innermost loop. Thus, for example, for loop, again one for loop within the braces, if disaster go to error semicolon and close the brace, then error colon. If the statements follow the label ending with a colon appear before a go to statement, the flow is in the backward direction and it is known as backward go to, otherwise it is known as forward go to statement. Statements in different places cannot have the same label. Consider a program to read a string using go to. Hash include stdio.h main within the brace char ch printf enter a string read colon ch equal to get char semicolon. If ch not equal to end of line, then within the braces put char within the brace ch go to read semicolon and close the braces. Now, let us summarize the points that we have discussed in this session. We started with loop control structures in C and covered for loop, the while construct and do while construct. The usage of the unconditional control structures go to, break and continue are also discussed in detail. Here are few assignments for you. Can the action of a do while construct be simulated by if or if else structure? Explain with an example. Under what circumstances will the do while be more appropriate than the for loop structure? Write programs using while loop and for loop to reverse the digits of a number. Write a program using do while loop to calculate and print the first n Fibonacci numbers. Let me give you some books for your reference. B.W. Kernighan and D.M. Ritchie, The C Programming Language, Prentice Hall, 1978. Greg Perry, Absolute Beginner's Guide to C, 2nd edition, SAMS Publishing, April 1994. Yashwant Kanedkar, Let us see, BPB Publications, New Delhi. There are many more other features in C programming language are remaining to explore. In coming sessions, we will study them more in detail. Till then, bye.